Welcome. This video is a demonstration video of our Type 1 number 362 Fuelless engine. This engine can be considered as a high-efficiency, free-energy electric motor producing and using DC and AC current. This engine motor can also be considered as a high-efficiency generator as well. The Fuelless engine is based on Nikola Tesla technology as well as our own technology. Free energy has been suppressed as early as the 1900s and is being continued to this day. No one can manufacture or sell any free energy device at this time. If you do decide to build this motor, you must keep it to yourself under lock and key. This motor is very special and cannot be purchased anywhere in the world, as we know of. You must build this motor yourself. It is not that hard. Supplies can be found anywhere on the internet. This can be a very easy homemade motor to build. You do not have to use special laser cut aluminum as you see here. You can use 3/4 inch plywood for your housing and motor ends. Unlike our Fuelless heater video, this video is not step by step. You will need the plans to actually construct this motor. Free energy is being produced in the form of back EMF and is being reused by the motor coils, causing this motor to be very high efficient. It is not a perpetual motion machine, but it is considered to be a free energy device. The back EMF can be collected by using a high voltage diode and a high voltage electrolytic capacitor connected to the opposite poles of the wire motor coils. Back EMF is free energy created from a collapsing magnetic field in a coil of copper-coated wire wrapped around a soft iron core or an air core. Back EMF can be used and collected in storage batteries or storage capacitors. By using thousands of lines of copper-coated wire in our motor coils, we greatly increase the capacitance and efficiency of the motor, causing the motor to use less amperage. If we input 1200 volts into our coils, it is very possible to get 4000 volts back. As the rotor magnets move past the large motor coils, the motor then acts as a high voltage generator. But because of this reaction, the commutator will produce very high voltage plasma arcs. And if not controlled by using small magnets in the area of the arc and commutator switch, the commutator will burn up. As you can see, it's almost impossible to try and stop the shaft by hand. This motor demo is being ran by 120 volt AC house current and being stepped up to 1200 volts DC in the small milliamps. For amperage demonstration purposes, we're using the 120 volt AC with a multiplier, DC multiplier. This motor can also be ran using a 12 volt car battery connected to a 75 watt power inverter which outputs 120 volt AC and then connected to our DC step-up converter to get 1200 volts or more. Most all free energy devices must have a small input of energy to get the free energy reaction started. Other free energy devices such as solar cells can be used to increase the motor's high efficiency free energy output as well. We are using 1 inch by 1 inch N38 neodymium magnets mounted on a hex shaft, which you can buy at smallparts.com. see I'm using N38 1" by 1" magnets. They're stacked. There's 1, 2, 3, 4 per stack. 1, 2, 3, 4, 5, 6, 7, 8, I believe. The plans will show you on that. North pole, south pole. In between each magnet is 2-part epoxy, and then we've got some 2-part resin on top of that. Use a hex bar, which you can get at smallparts.com. Very easy to construct. Again, supplies can be found on the internet. The motor can also be ran by using 240 volts AC, European voltage, connected to a step-up voltage multiplier using our number 378 plans to change the voltage from 240 volts to 1200 volts DC. That's the back and the top on what you're doing. That's how much voltage buildup happens inside the coil. In another video, the motor can be seen only using small milliamps of current, using a small input and getting a large output of horsepower and energy back out. The RPMs can be adjusted by using less or more voltage. This can be done by using a rheostat. Or another way is to tap into the lower voltages of the high voltage step-up multiplier. See our plans number 378 for $9.95. For demo purposes, we are basically showing you a cutaway view of our motor. We are using only one coil. This motor is designed for a 2-coil use. Each coil can be used to pull the north pole and the south poles of the rotor magnet, which will greatly increase the power of the motor than only using one coil as seen here. Again, for demo purposes, we are using only one coil and one set of brushes to turn the north pole of the rotor magnet. You could use all 4 sets of brushes to alternate the DC current at the proper times of each rotating cycle and cause the one coil to pull both the north pole and the south pole of the rotor magnets, which will double the horsepower that we now have here. If another coil is placed on top, the first cycle of these coils would be as so. The top coil would be producing the north pole flux, and the bottom coil would produce a south pole flux. Both coils would be switched on at the same time of the first cycle. At the second cycle turn, the polarity would change for both coils via the communicator brush switching. Here we are using brass spring sheeting, which we cut to size to make our brushes. Of course, common carbon brushes could also be used as well. course, I could connect a generator to this with no problem. Any type of size generator. Well, not any type of size, depending on the horsepower, the output, and the RPM. I recommend our SP500 generator for $70. Some examples, of course, in our research we've made a lot of different size coils, different types, different ways of winding. And this will give you some idea of what it looks like without the covering. Because on the outside we have a plastic covering. It's chrome, which you can get at art stores, art supply companies. It's just to help protect from arcing, and it looks good too. You can also use number 28, get more horsepower, thousands of turns, as many as you can get on them. Neodymium magnets, of course these ain't the 1 inch for 1 inch, but just an air core. Okay. Hopefully that'll help you in your construction efforts. Now let's take a look at the amperage it takes to run this motor. With no load, a motor of this size and torque would be using about 3 to 4 amps to run. But this motor is only using about 10 to 15 milliamps. Our power supply is a common capacitor and diode multiplier that uses special photocaps. This motor coil is rated at 2,200 volts DC. I can run this thing all day and it's not going to use any electricity hardly at all. There's no way I'm going to stop it at all. I'm trying my best. I'm trying, everything I got to stop it is not stopping. And here we go again. Watch the meter. The amperage is going to go way up. When I disconnect it, now. Whoa.